Oh, the wonders of alien life, the unimaginable creatures that flood sci-fi films, and more. Unfortunately, none of them skim the surface of what xenobiology truly is, let alone astrobiology, other than James Cameron's Avatar, but that's another story. Xenobiology translates from Greek as the study of foreign life, but more accurately, the study of estranged life forms. It was first mentioned in the 1950s by a man named Robert A. Heinlein concerning life from outer space. Then in 1965, they used it to describe drugs, and in 2010 for lab-grown organisms. In the end, no matter the use of the term, whatever they were describing must have obeyed the definition of life: the ability to grow, adapt to an environment, have a working metabolism, and most importantly, have the ability to reproduce. Xenobiology can include speculative biology, the microbiology of extremophiles, and synthetic life. That is why we are categorizing them into 3 sections: exo, terrain, and synthetic. But what about astrobiology? Isn't that basically xenobiology? Well, yes and no. Astrobiology includes xenobiology and astronomy, physics, chemistry, etc. of the solar system the alien life form lives within. Xenobiology is the specific makeup of the creature itself, and itself only. Here's a diagram of how and where these fields of study would be laid out. As you can see, the more we venture out into determining how an individual life form may look like, the more unknown it becomes. Since we know how life on Earth works, we can understand how some alien biology may look using experiments on Earth that replicate conditions in space, but we can't entirely state how another organism would look like on another planet. We would need to find an Earth-like planet that orbits its star's habitable zone, where life can be suitable. However, there are attempts in the speculation of life beyond these boundaries, being almost entirely engulfed in the idea of speculative biology, also known as exoxenobiology. Since we have yet to discover life out in space, we can only speculate using the available scientific research, that and art to create a semi-accurate reference as to what life may be beyond the Earth. But Earth in itself is quite a rare occurrence, thus creating the rare Earth hypothesis, but more importantly, the great filter. Reasons for this are that the alien life forms either haven't reached our level of complexity, or that they have become so advanced they were driven towards extinction through war and resource scarcity. But no one can entirely prove this to be true, since we currently lack the evidence of any other life form. Aside from space, xenobiology can exist in systems hidden within Earth itself. These life forms are coined as shadow life, and the closest way to find such life is by taking a look into the realm of extremophiles, which are tiny, nearly indestructible creatures. You are quite familiar with one, the water bear. It has the ability to withstand the cold, heat, dehydration, radiation, acid, and even the vacuum of space. Unlike exoxenobiology, terrain xenobiology refers to hidden life with potentially different biochemistry and metabolisms. Such discoveries in this field can open up a new view on the evolution of life, and it can even raise questions as to whether there could potentially be life that is systematically complex yet structurally simple. The third form of xenobiology is a subfield of synthetic biology. This field simply aims to create a new life form that has never existed before. Looking into biotechnology, we can mimic conditions of early Earth life and move backwards to create a new life form. This almost solely refers to genetic engineering, changing and altering different chemical makeups to override pre-existing functions, or even add new ones. It is also possible to create nucleic acids with differing sugar backbones, first mentioned by Herdouin and Marlier, with xenobiotic nucleic acid, also known as XNA. Some of these include hexatyl, arabino, fluoroarabino, cyclohexene, peptide, etc. These all have the ability to evolve and self-catalyze, break apart, similar to DNA. There has been one test done combining XNA with unnatural nucleotide pairs to create a new life form via in vivo. It involved a reporter gene that expresses bacterial polymerase and a DNA ligase. Since XNA cannot combine with DNA, there is a promising future in the prevention of genetic pollution. It is possible that in the future there will be larger synthetically built life forms, separate from that on Earth. Overall, alien life can be considered anything that is unlike that on Earth, anything man-made, outside the atmosphere, or unlike the majority of that on Earth, can be considered extraterrestrial.